Tourmaline is one of these minerals that exhibits color zoning, which is a phenomenon which is exhibited by various different kinds of crystals, but tourmaline does this in a really magnificent way. So this is where single crystals or long prismatic crystals might display different colors along its length. Sometimes it's two, sometimes it's three, sometimes possibly even more. Now, this is where the classic example is watermelon tourmaline, where the core is pink or the red and the rim is green. However, when you see a crystal that's distinctly one color on the top and another on the bottom, like this, especially along the length of the crystal, the technical term for this is axial zoning or sectoral zoning. So if the zoning follows crystallographic sectors. So more broadly, it falls under the umbrella of color zoning, which just means color variation within a single crystal. So chemically, tourmaline's color is controlled by trace elements. This is the same for many minerals. Tiny amounts of metal cations that substitute into the crystal lattice. And in this context, the main culprits are going to be things like iron, magnesium, sometimes, although rarely, chromium or vanadium, which tends to contribute to things like green. Now, during the crystal's growth in a fluid-rich environment, the composition of the fluid evolves over time very slowly. So imagine a magma chamber or some kind of hydrothermal pocket that slowly crystallizes. Now, different elements become more or less available in the fluid as that crystal grows outward. So early on, there might be more manganese available, so the tourmaline incorporates more manganese into its structure, often yielding things like pink. Then later, if that chemistry shifts, let's say with something like iron, the subsequent layers of the crystal incorporate iron, switching the color to something perhaps like green. Now, this is essentially a record of the changing geochemical environment in which that tourmaline is actually formed. It's not the be-all and end-all because there's other factors like redox conditions, temperature, pressure, but this is more or less a summary of how this can happen based on other variables. So the phenomenon is called axial color zoning, or more broadly, just color zoning.